Okay, so let's get going then. Git repositories. I was speaking about Git versus TFVC, Git, the new kid on the block, distributed version control system, TFVC, client server. You guys coming from SVN. Okay, so what did you want to see around Git? Shall we just go through a quick primer on Git? Let's go. So Git, distributed version control system, is one of the newer versions of version control. The difference between Git and something like SVN or client server is that you must realize that you actually sit with the entire repo on your machine. So when you do a clone, there's different processes on how you start with Git. And the first thing you do is you clone the repo, and that is exactly as it sounds. You actually clone the entire repo to your environment. So that brings down the full history. So if I have a look and I say, let's go and go to my master. Oh. Can everyone see that? So the first thing you do is you clone the repo, right? How you get started, and there are different ways of doing it. Obviously, you all use Visual Studio, pretty much. Okay, so Visual Studio is fairly simple in that when you say connect to a repository, this should look vaguely familiar, right? Yes. Not necessarily the fact that you sit and wait for it, but there's your repository, clone, right? In this case, I've already cloned it, so it's not asking me to clone it, just says connect, but there's my clone option, right? So this is probably the easiest way to get started. If you are hardcore and you work with your command line, you want to say git clone, no, repository into the current directory. If I now go into Visual Studio and open a directory, okay, you will see the full history sitting there, even though it's not actually connected through Visual Studio to a repository in Azure DevOps services. So Visual Studio only sees that there is a Git repository, and that is the history that is associated in that Git repository. I can disconnect it to, and it will still show me that full history, and I can move back and forth. The difference between that and, for example, SVN or TFVC is you can see what changes you made since the last version that you updated, but that's about it. You can revert those changes. I've got the full history here. I can be in this repository and I can go and create branches. I can merge between those branches. I can make changes. I can commit it locally. All of this stuff without needing to actually push it up to the server. When I'm ready to push the stuff up, then I will push and then make it available on the server. So Git repository, make changes, commit, happens locally, To get those changes, you must synchronize it to the server by either a push or a sync that does a pull and a, or fetch and a pull and a push. Okay. So simply speaking, if I connect back to my, some of you have worked with it, some of you haven't, so I'm going in a bit more detail. Here's this one. So, if I make a change, I'm making this, I've opened up this repository, I'm sitting on a Git repository that I've cloned previously. I made a change in my Team Explorer. If I go to changes, there it is. Oh, ask me for my, who I am. And I'm going to say local change. And I'm going to say commit. If I go and have a look at my history, you'll see there's 3 changes. I've made a commit, not on the server. So next step is, I must go to synchronization. You'll see there's an outgoing commit. This is the commit that I made locally. There's no incoming. So this idea of fetch and pull. Fetch merely goes and connects to the server and says, what commits are there that I can possibly bring down? It's not going to do anything. It's just going to tell you these are the commits that you need to bring down before you can actually commit up. Pull actually brings them down. So if there are merge conflicts and stuff, it will then raise up then and say, well, there's actually changes made. You need to sort out this merge conflict. In this case, there aren't any. You can click fetch. Oh, there's not. And when I'm ready, I can say push this. Okay, pushed it up, and if we are lucky, we'll see that commit up there. Okay, there we go. Everyone happy with that? So it's 2 steps instead of 1. The catch here is that locking files and that kind of stuff that was available in something like SVN is not necessarily available here anymore. There are ways of locking files, but we won't go into that much detail here. Primarily you're working in your own environment. And the same goes for branching. So I can go and create a branch off of my local. Can change my context to this branch, can make a change, change my context back to master and have a look at the change there. Okay, so once again, the difference between, from a branching point of view, between SVN and TFVC is where those represent branches as actual folders. You basically have a copy of the files that you're working with. Get the context changes to the branch that you're in. So at any point in time, you are looking at it in the context of the branch that you're working. If you want to change to a different branch, you either need to commit these changes and then swap context to something else. The reason for that being is the branches in Git is more explicitly managed by diffs than anything else. Okay, in TFVC there are actually circumstances where duplication can occur between the files, so it's a more streamlined way of managing it. Okay, so once again, how do I get my change back into master from my branch? I will say merge from my branch and merge it into the master. See, it's already committed that for me, so it's taken those changes. If I go and have a look at, here's my history, see, there's the change that was made in the history of my master branch. And I'll actually go into detail about how the branches itself work, but there you go. So we've created a branch, we've created a clone, we've committed, we've pushed, and if I want to show you pull, so I can take this branch and I can push it to the server. Where is this? If we have a look at all branches, see there's only one branch. If I commit this branch, let's see. Taking way longer than it should. Let's see if I've done it. No, still not. So I haven't done it in the context of the branch right now. I'm in the master branch. So let's push this guy. Push that guy. Jeez, and there's my branch sitting on the server. Okay. Oh, what I wanted to show. Let's go to the master and let's make a change in master. It's going to be a long afternoon. Okay, come down here. If I say fetch, you'll see that there's now a commit. Oh, not in there. Change to my master branch. There's a change that I made online. Okay, so there's a change that's not in my local. So if I make a change here and commit it to my local environment, so and I say pull, this will hopefully give me a merge conflict. There we go. So now it's telling me that there's actually a conflict and put some garbage into the file. I don't quite know what that is, But now it's up to me to go and fix that file before I can actually merge it down locally. So this is going to say in the sort of conflict error state until I explicitly say this is now sorted, carry on. So I can go and compare the files, say keep local, commit, and there we go, we are merged. Okay, does that kind of make sense? So merge conflict. So we've got local branches, we've got server branches. We can synchronize between the two. We can commit to local environment and we need to push it to the server environment. We can work in the context of branch. We can have a full branch structure sitting on our local environment that does not exist on the server. Once we are happy, we can merge it to a server linked branch, or we can push our branch to the server that it exists on the server. When we've got changes sitting on our server that is conflicting with changes that we made locally, it will bring up a merge conflict, and then we'll have to merge it manually. And once we are finished with that, we can then make those changes, commit it locally, and then push it up to the server, and then we are up to date. Kind of makes sense. Okay, so, while I'm busy with this, if you look at this guy, if I refresh, make sure I've got all the changes. Of course, all of this is available on the command line too. So any Git client, so if you've got command line, obviously, so you've got Git pull, Git push, Git clone, all that kind of stuff exists. Anything that has a Git interface, so Xcode, NetBeans, your Java environments, or anything that understands Git, that can work with Git, you can use against this Git implementation. Come on. Anyway, okay. Getting back to this whole integrated fashion or integrated notion in Azure DevOps, I've made a change here and I can commit. So in my comment here, I have this idea of the hash notion. So if I say hash 123, it will try and associate this commit with a work item ID 123. I can do this explicitly using the interface here, which seems to be taking forever to load. This is the after lunch lull, I suppose. Come now. Task. There. 216. Okay. I can associate it directly, and I can do, of course, the same through Visual Studio. If I go and have a look at changes, there's my related work items. If I add here, it will actually bring up the queries that I've got specified, and will show me actually, let's see how long, wait, let's go to no, it's also taking forever. Anyway, so I've selected the task 1. If I commit here now, commit, any questions? Oh, there we go. She's like my freak. Okay, any questions? I'm going to restart it now. I'm actually going to skip ahead to the slides while this thing reboots. Okay, so I've committed it and I've associated the work item. If I can have a, oh man, if I look at the commit details, you should see, oh, there we go. You should see, oh, there's a build kicked off, but anyway, there's one work item associated to this change. Oh, that's probably why this thing's taking forever. Builds are kicking off. Anyway, you can see there that that task is associated to this commit. If I go and have a look at this guy and I say refresh, you should see there's the check-in associated to this. And just so happens that the build that was kicked off as part of that check-in has also passed and is succeeded. So if I go and have a look at the build log, you should see there's the associated changes in this build, and there's the work items associated to that build. And ready roll apparently failed to. Let me just uncheck this trigger. That might be one of the reasons it's taking forever. Okay, so git push pull clone associated to check to work items that is proliferated. Is there another build in progress? No. So while that's restarting, let's look at a few slides. Okay, so sorry. Clone, commit, push, pull, branching, merging. I'm going to show you the pull request now. So branching strategies. Branching strategies is one of these very contentious issues. There's a lot of them depending on who you go and talk to. There's a few sort of standard basic ones which are more sort of common sense, common knowledge kind of approaches. This, for example, is a feature branch. So we've got a master. Master is sort of the trunk in the SVN world. Okay, this is the base branch, and how you work with it differs depending on the branching strategy. So the first one, and probably the most simple one, is you create a branch, do the feature or bug fix or hot fix. As soon as you're done with it, multiple commits, you push it back into master, off you go. Okay, that's sort of your sort of stock standard basic branch. And I'll also mention at this stage that branching, regardless of the repository, the simpler the branching structure, the easier it is for everyone. Okay, you want to keep it as simple as possible. Okay, feature branch, you create a branch when you start a new feature or a hotfix or a bug, and then you push it back into master. Obviously, I'll talk about trunk-based development just now. Release branches. So once you've created, once you're ready to do the release, you create a branch for the release, and then you work off of that if there are any fixes or bug fixes or issues. The idea behind this is that you are segregating the code that exists in your target environment. So if you've got a production deployment, you want to keep that code separately. There's a couple of ways of managing it. You can either do a full-out branch when you are ready to release, or you just tag it, and then at a later stage you can branch from the tag in Git. But ultimately, what we are trying to accomplish is to say we have version 1 of the release. Okay, we might get to a stage where we are actively developing, so the version on your master or dev branch is far ahead of what the release may be, and you don't want to make a fix in your code and then deploy everything to production. So we have a branch that represents that release. When you get ready to, when there's an issue or a bug fix, you can go to this branch, make the fix, push it into production again, and you know that the code that was in production now is what has been fixed, and only the change that you made to fix the issue has been pushed back into production. Then what we would do is we would then merge those changes back into your master branch, so that you want to keep those changes in your active development environment. Does that make sense? So you've got your master branch. When you release, your release gets a branch or a tag of its own. When there's an issue in that production, the code in that branch looks like what production looks like. So when there's an issue in that, you can fix it on the code that is similar to what is in production without including or making changes to the active development environment. This is just using that same kind of approach using tags. So you can also work off of tags, branches, and create the branch off of the tag when you're ready. So SVN also has this concept of tags, so similar approach. Okay. Now, this is one of the well-used branching strategies out there. Has anyone seen this one yet? This is Git flow. This is complex. I spent quite a bit of time trying to figure out what is happening here, but it's just a mess. And this all comes down from the notion that you can actually merge between non-related branches in Git. So you have the master, you start a dev branch off of that master. Off the dev branch, you'll create a feature branch, and then your active development actually happens here. Once you are happy here that the feature is complete, you move it back into there. If there's an issue in the master branch or the production, you'll create a bug fix, in which case you want to merge it back into your master and into your dev. Okay, so here, same approach. When you are getting ready for release, what you'll do is you'll take a snapshot of your dev branch. For the release, you'll verify it. If there's any changes to be made, it needs to get back and pushed back into your dev branch. Once those changes are fixed, then you can move it back into, or the release branch is ready to be released, you move it into your dev branch and then back into your master branch from where you would actually release. Simple, right? So this is one of the probably older, there's a lot of literature and there's actually books on this. There was a thing a while back. If you want to look at the complexity of something, you look at the number of books that are available. So, for example, SVN, there's like 1 or 2 books. In Git, you can fill a section in a library. I don't get books associated to Git, but anyway, Git flow, similar thing. So the new approach to this is actually GitHub flow, which is a bit simpler. Now, this is more reminiscent of trunk-based development. So at any point in time, this is your master. When you start development, you create a branch. All the development happens here, all the bits and pieces. This just means that there's discussion here when you're ready for it. Once this is finished, then you merge it back. Done. So GitHub actually uses this approach in talking about the definition of done. They've got Squirrel sitting here, which is a build system. The end of this, it actually gets deployed into production. When it is in production and there aren't any issues, then it gets merged back into the master and it's done. So their definition of done is in production without any issues. This actually also talks a bit more about pull requests that we'll cover now once my machine's back up again. But simple, straightforward, you basically have one branch, all development happens in there. The next one, also sort of related to trunk-based development, is using feature toggles, where you actually just have one master and all the dev happens on master, and stuff that is not ready to be deployed gets hidden behind feature toggles. So if you check in 10 times a day, there's actually 10 deployments happening to production a day. Amazon, it's now actually a few years ago, they were deploying to production on average every like 11 seconds to one of their systems. Etsy.com, which is a major retailer, they were doing approximately 30 deployments to production a day. Azure, like I said, they do between 2 and 4 deployments to production a day. And it's all based on this concept of every commit, continuous delivery, every commit gets filtered through to production, but if it's not ready for consumption, it just gets hidden behind a feature toggle. Of course, feature toggles in itself is also problematic. If you're not doing it properly, you can have big issues, but that's a discussion for another day. So, branching structures, you decide what makes sense to you. More often than not, it's just a simple release branch. You work in master. When you're ready to deploy, create a release branch, deploy from the release branch. Simple, straightforward. There are other ways of doing it. Any discussion points? Anything? Questions around it? Okay. Merging. I will show you policies now. So when we talk about merging, there's actually a couple of different techniques in merging itself from a Git point of view. The TFVC, SVN, it's pretty stock standard. You merge, you have a change set sitting in the branch that you're working with, done. Now, Git is not really that easy. So it can get fairly complex. So if we look at this one, first one, that's a standard merge. So if you look, this is your branch. These are the changes that happen in a branch. When you're ready to merge this change back into your master, there's a change set sitting in master, and that is what you'll see. Okay, if you want to go and see what the individual changes were here, you'll need to go into this branch. A squash commit is interesting in that it will take these changes and it basically disassociates this. It throws that away and it commits it in there as one commit. Done. So there's no actual even indication that there was a branch, for all argument's sake. Okay, that's another way of doing it. Rebase is probably the most problematic of the lot. It will take the history that you are building in your branch and actually merge that history into your master branch. I've had lots of people have lots of problems with this. But that is a very nice way of pulling the entire history of the branch into your master branch. So you can see exactly what has happened. Problems with merging, problems with people losing changes because you can actually overwrite history, especially if these commits happened out of sequence. There's a few problems around it. It's few and far between, but it happens. Merge conflicts are probably your most prevalent. The squash doesn't throw away, but it throws away basically the commits that, or the association to that branch. Yes. Yeah, it can still exist. You can go and delete it, yes.
So how do you reliably transfer your history of the branch?
If you want to transfer the entire history, then this is probably one of the ways of doing it. Otherwise, you just go and create a normal merge, and then you'll actually see the graphs as where the commits come from. Let's see. So you can see there's a branch that was created, and there it was merged back into the master branch.
Right. So any commit on that branch was taken out, and you still had those items there.
So you would see that, and over there you'll be able to see what was part of that commit. But that's pretty much it. You would need to go and trace through the individual commits. If you want to see that there were 10 commits on that in the branch before you merged, you'll need to track it down the branch. Come on. Apparently okay. Anyway, what is this for? Whatever that is. So that basically takes your current branch and rebases the branch to your current head. Those are the four options when you're merging in Visual Azure DevOps actually. If we go and have a look at why can't I merge here between them? You know, ask for pull request. Anyway, it's behind, not in front. Let's carry on. Okay, we're not going to do that. So, stepping back a bit, merging, we've discussed now a few merging concepts and a few ways of merging, depending on how how prevalent you still want the history in your master branch. So okay, we want to take these changes, we want to create the branching structure, we want to do the merging, but we also want to protect our master branch. So there's a couple of things that we can do around that. So one of the things that we would do is, let's see if I can remember where to do this. Okay, there we go. We can set up policies on our branches. So we can decide what kind of criteria we want to fulfill before we can merge to this branch. And this is one of these things that you put in place, especially when there's a lot of churn, when there's a lot of issues with quality control. It's a way of keeping your master branch sane or of a high quality. So we can set up these policies between the branches. I can say for the master branch, it needs minimum number of reviews. There's the check for linked work items you were asking. So I can enforce the fact that you can't merge to our master branch from a branch unless there are work items associated to it. I can allow that. I can say kick off these builds. If these builds passed, then it will allow you to merge them. If it doesn't, it will just disregard or reject your pull request. So require enforce merge strategy. There's the different merge strategies that we can apply to this. So if we want the full history, fast forward, no fast forward, that's the rebase, and then squash merge, so everything gets committed as one thing, as one change set. And let's save this. So once I've set up this policy, I should not be able to commit directly to this branch. The only way for me to get a change into this master branch now is to actually Okay, so once I've made all the changes that I want in this branch, then I can do this through Visual Studio as well. So I can create a pull request. This basically goes and opens up the browser in any case. So I can say create new pull request. I want to merge my changes from this branch into master. Their description. I can ask different people to do reviews, associate work items with this, see what the changes are, and if all this is fine, I can create. So this will create a pull request, and this is now a management structure. So the pull request exists. The changes aren't merged automatically unless you set up your policy to be able to do it. So you can set up, it's already failing because there's no work items associated to it, but anyway, you can set up policies, so if a build passes, then it will go through automatically. In this case, it's going to wait for reviewers, and I can go and have a look at files. I can add comments, so the discussion on this, what has changed, are there any changes that must happen. I should be able to I used to be able to create work items associated. Comments, updates, commits, see what the commits are. Once this is done, I can approve it. In this case, it will fail because I have 2 reviewers and no work items associated to this, so this will not actually get approved because it's failing some policies. Okay. So there's one approved. Now it's going to sit and wait for someone else to approve it as well. Did I add 2 approvers? Yeah, I did. Oh. So now it will sit. Once the other person has approved this, then it will actually create the merge and then merge back into master. Interesting. Oh. Anyway, yeah. Okay. Let me just check that quick. Interesting. Yeah. Is it? I just thought that this gives you the ability to segregate who needs to review it. Anyway. Yeah. Okay. So if that auto reviewer is not working, then you should be able to log feedback there somewhere. Log feedback, let them know. Yeah, report the problem. One, two. Okay. So, repositories, Git, pull, push, clone, commit. Obviously, creating a repository is as simple as creating a new repository. I think I showed that earlier on. This git ignore actually does help quite a bit in keeping the clutter and additional binaries and stuff that you don't need to commit to your repository, so NuGet packages or whatever the case may be. I generally use that quite extensively. We looked at some branching strategies. Okay, any questions, any comments, any feedback? No, so stakeholders cannot see repos. Yeah, I did a fairly big upgrade recently from 2015 to 2018, and about a week after that, it was a 7-month process where we went to everyone explaining exactly what happened and how the changes are going to be affected. So, but it was a week and a bit afterwards I spent pretty much every day there on site because everyone was disgusted that they had to pay for a license to be able to see stuff like code and builds and that kind of stuff. Anyway. But yeah, so literally I think what you'll see as a stakeholder is overview, boards and test plans. I think not sure about pipelines. Okay, anything else? Nothing? Everyone happy? Okay. Okay, so let's look back at our slides. Okay, TFVC we're going to not cover, so pipelines. Azure pipelines, build and release. Yeah. So this is an interesting topic. Pipelines is, back in the day, TFS had XAML builds, which were old and disgusting. This concept of build controllers and build agents, and you've got a XAML flow, which is a workflow foundation workflow, which was horrid to update, but it was possible. You could change it, and basically your build definition was a bunch of parameters that you fed into this huge XAML file. Okay, so that was fun. In any case, this is one of the newer functionalities. So they actually rewrote this circa 2015-ish. They rewrote the entire functionality, and it seems like they're busy rewriting it freaking every couple of months. But this is a modern take on the build pipeline. It is cross-platform, so it runs on Mac, on Linux, on Windows, the build agents. They've changed the concept of how they operate, and now that they have this concept of a pool, an agent pool. So you create agents. Agents is a bit of software that is running on a machine that actually performs the work of your release and your build. Okay. It is the cross-platform thing, so it can run on Linux, on Mac, on Windows environments. You associate agents, and you can have multiple agents on a machine. Generally speaking, the guidance is that you have up to one agent per core on the target machine. You'll associate it to a pool, and that pool of agents can then get shared across your collection in Azure DevOps. And the same applies if you're working on premises or on services. You can have a agent pool set up locally, agents running locally associated to Azure DevOps services, which then obviously means whenever someone checks in or trigger fires or you create a build or a release, the instruction gets handed down to the agent here and it will run on premises. So it will have access to your machines, your environment sitting here. Okay. Yeah, any language, any platform, that's kind of the approach that they took with this. I tend to tell people that, you know, the pipeline is an orchestration mechanism. It will do whatever you want it to do. If you can include it in one of the tasks that exist, if you can run command line, it will do whatever you want it to do. It is merely an orchestration. It can bring these things together and it will perform whatever you want it to do. It is extensible. Like I said, there's a bunch of tasks and we'll look at it now. They're actually busy rewriting the editors and stuff into YAML, which is crappy, but anyway. Who works with YAML? One person, shame. Yes. Probably. There's pros and cons. So the whole idea behind it is, so yeah, feature parity is getting there. So if you look at let's take this guy. Here's this one. Okay, so step back. The reason for them using YAML is YAML is now a file. It's associated. It's a file of space indent or tab indented instructions, task, attributes, whatever the case may be. The reason they're doing that instead of the current approach, the current approach has the mechanism of catching the history of updates to your pipeline. But what they are doing now is they're changing to a YAML file, which is a file, it's a definition, and it sits in a repository. So you've got full repository-based versioning on that file, which also means that the YAML file is now associated to the repository and its code. So if I've got a YAML file that builds version 1 and 2 of my repository, but in version 3 we go and change everything and anything. If I say build version 2, it'll pick up the YAML file that builds version 2, and it knows how to build version 2. If I go to version 3, it will pick up the new updated YAML file with a new updated code and build version 3. So that's one of the big drives in going the YAML route. And obviously also there's an open source sort of feature that they're targeting the open source community, so in GitHub. And what they're giving you, actually, if you've got open source GitHub projects, you can use Azure Repos up to 10 parallel builds for as many minutes as you want for free. And this is kind of the way so that YAML file will then live on your GitHub repository. So it's a way of also taking that kind of segregated approach. So you can move that YAML file and live somewhere else as opposed to having the definition that is only maintainable through Azure DevOps. That said, there's still quite a bit of work. So this is actually Azure DevOps services. if I go and have a look at, let's say, create a new pipeline. Here I've got the option, this little hidden away sentence here at the bottom. That is generally what I use. Okay, so this is the classic editor, and I'll take you through the classic editor now. The YAML editor is not yet on premises because they are still working on it, but it is available here. So I'll show you this. Now, the parity thing comes in that obviously I now have the option to go and pick where do I want to build from. So I can go and use GitHub, other Git repository, that other repository sitting there, or say Azure Repos. Notice that TFVC is not included out of the box there. Anyway, so I'll just pick a repository. It will go and create a YAML file for me, and these are just the tasks, and I'll show you what the tasks actually look like. Now, great, there's tasks, right? There's some notion of IntelliSense built into this, but that's about it, right? If I want to add a new task, I need to kind of know what I'm looking at. So, two gripes that I have with this, and luckily I'm not a Microsoft employee, so I can cut them out. Firstly is a feature that I'll show you now, and secondly is this button. The only way for me to save this thing is to execute to basically run it. There's no concept of just save the damn thing without executing it.
You have the release will up every time you save, you trigger a build.
So the first time I create it, this is a build, so the releases I'll get to a bit later. So this is a build. The first time I create it, the only way to save it is to run it. I'm a saver. I hate this nonsense. I must save at least 10 times before I actually think about running it, especially if you go back and forth version to look at the classic editor and get the YAML out of that and then copy and paste it. Okay, so that's why I've got a horrendous amount of cancel builds, but anyway. So now I've got the initial, so it is clever enough to have a look at the repository it's pulling and sort of decide if it is a ASP.NET or a Python or a Java build, and it sort of caters towards it. Fair enough. But see this functionality here? This would have made things a crapload easier if they actually just built it in the first time you create it. The only way to see that, and this is just adding new tasks to your, so if I wanted to go and add a new task here, let's say you guys use Python, let's look for Python. There, Python script. If I go and say script path, arguments, add, if they just added that in the freaking first time you go and create it, life would be a lot easier. But it's not there, but it's here. And there's still some issues around this. And they're also now adding this, they're adding you the capability to create release phases in here as well. So then this will actually have your release phases. So that's just different notation, but yeah. Anyway, so that's my gripe for this so far. Anyway, if you look at the classic, I think that's one. This is the classic editor. So there we've got pipelines where we can say which pool we are using. This you can set up in another one. I'll probably show you just now. But we've got agents. So there's an agent job phase, and in there we've got tasks that we can go and add. So as you can see, there's quite a few tasks that you can add, and then you can just build this up, set parameters, and then once you are happy, and let's do and you can just save it. You don't have to save and queue all the time anyway. And then yeah, there you go. So that's the difference between the YAML and the classic editor, which I still use most of the time. Once you've done this, then you can see the YAML and copy and paste that and create a YAML file if you really wanted to. It'll just warn you about all the linked variables and stuff that you're using, which I'll cover now, but anyway. Have I griped enough yet? I don't know. Yeah. Okay, so let's start at the beginning. So this is Azure DevOps Services. Azure DevOps Services gives you the ability to pick a bunch of hosted build environments. Out of the box, you get like 1,800 minutes for free. If you want additional time, you actually have to, you have one concurrent build that you can run. If you want additional, you need to pay for it at this stage. Once you've got an additional build, then you have unlimited minutes, and then you just pay for every additional pipeline you want to run in parallel. Okay, that's it. These are all hosted environments that default from there. The private on is where I can go and add on-premises versions. And you guys, what version of MSDN do you use? Yeah, Pro, Enterprise, Pro. Okay. So for every enterprise, you already get an additional pipeline that you can use on premises. Anyway, so like I said, these are all hosted. So you've got Mac, you've got Linux, you've got Windows in containers, you've got Windows 2019 with Visual Studio 2019. You can use these up to obviously your allocated minutes. By managing these, the way that we add new agents is a very complex job of going to the pool. Where's my pools? Let's say default. Click new agent, download, and basically run that. That will then ask you what is the server that you're trying to add this into. Then it'll ask you what's the pool you want to add it into. Then it'll ask you under what service account you want to run it, where do you want to have the working folders, and then your agent is added. Pretty much stock standard. Like I said, you can have multiple of them running on your machine or your server at the same time. It's really up to you. And then also, if you want Linux or Mac, same kind of approach. And that's how you add additional agents. So like I said, you get one out of the box for free, and you should have on your organization come now. Trying to see where's my usage. There we go. This is not what I'm looking for. Ah, there we go. This is what I'm looking for. So here you'll be able to see how many allocated jobs you've got. So I've got one parallel for the free tier 1 up to 1,800. I can have 2 parallel jobs because I've got a couple of subscriptions and so forth. That's new. Public projects. Okay. That's your agent pool. So agent, you can go and download it, create a new pool, associate the new pool to your build agents, and then all the actions that will happen where that agent lives. Okay. If it needs to pull down source, it will connect to your repository, pull it down to that machine, and actually do the compiling, do whatever, run scripts, etc., on that. And like I said earlier, what happens on that is defined by these tasks. These tasks, if you are brave enough to do it through YAML or through the classic editor, these tasks are simply just one task after the other for your build environment. We use the builds to create artifacts. So if we look here, it's got two sort of concepts. You've got pipelines, which is renamed recently, apparently. See, I still know it as builds, but anyway. So that must have been in one of the new. See how frequently they update things, even I get behind. But anyway, so pipelines is what they use to create the artifacts. But that's a bit contentious because they're using YAML builds and they're actually incorporating release methods into the pipeline, so that's why they've changed it to pipelines. Anyway, builds create the artifacts, releases, we'll take those artifacts and actually deploy them where we need them to be. So builds, generally speaking, we would go and compile, do whatever we need to create those artifacts, run tests, unit tests, that kind of stuff, make sure that the quality is high, do static analysis if we need to, using something like SonarQube or whatever the case may be. Then we take those artifacts and we'll create a release environment, a release, and then take that and deploy it into the different environments. Now, this is very similar to what the pipeline or the builds work in terms of tasks and stuff, only we've got additional capability of grouping them into release phases, if you want to call it that. First off, we'll start and say, well, what do we want to release? And we can add artifacts. And those artifacts can be part of the build that we've just created. It can go and pick it up off of source, files, GitHub, TFVC, Jenkins, Docker, you name it. We can pick up artifacts from wherever, be it an artifact store, the Azure artifacts, it doesn't really matter. We can go and get those artifacts. Then what we will do is we'll take those artifacts and we'll start releasing. So firstly, in this case, I've got one dev stage, and I can say to start off with, how do we want this to be approved? So before it, in this case, releases to dev, I want someone to actually say, yes, go ahead and release it to dev. So think of taking a test environment. You want testers to say, okay, or test manager or whoever to say, okay, move it into test. We are ready to work with it now, or just hold on for a while before we are ready for you to take on the new changes. I can say, schedule it. There's my pre-deployment approvals. I can specify who I want to deploy, approve it, specify timelines. So if they haven't actually done anything after 30 days, I can reject this deployment, or I can just approve it and carry on. These quality gates is if we want to automate that approval approach. So what I can do here is I can go and pull a third-party system. So I can say, run a query with all the bugs there, query work items. I can say run a query for this iteration, and as soon as all the bugs are cleared, then you can carry on and deploy, for argument's sake. Then it'll just automatically deploy. It doesn't actually sit and wait for someone. When you sit and wait for someone over here, it'll actually ask you for pre-deployment approval. It'll ask you, when do you want to deploy it? If you want to deploy it now or tonight at 12 o'clock, it's up to you. You can actually delay this deployment until you are ready for it to deploy. Okay, once you've bypassed all those, then the actual deployment stage kicks off. And this, if you have a look, looks pretty similar to the build environment, right? So we've got phases here. I can go and add tasks and do pretty much whatever I want to do here to take this and deploy it. And this can be from database deployment to migrations to IaaS deployments to Azure deployments, copy and paste. If you really wanted to, you can do Xcopy deployments. What we would also do here is this concept of variables. So the build and release has a similar concept of variables. I can say, give me a, let's say, site name. For there, I want to say dev. I can then use this wherever I use as a task in here. So if I want to say, let's go with the IaaS approach. I want to say deprecated already. I can reference that variable like that. So this would actually go and have a look at variables in the dev phase, and it will pull down the value and change that value there at the runtime. So this means I can actually take the same set of steps and duplicate them over into a QA environment and then just update variables in QA. So it will look the same, but in the QA the site might be called something different. And there's some tokenization tools and stuff that will actually look through web config files for connection strings, that kind of stuff that you can replace on the fly, depending on where you are deploying to. Because obviously your test database and your QA database and your production database, they would hopefully be different databases, right? So we can do that using this concept of variables. In this case, like I said, the scope, we can scope it to release or dev. Your pipelines, same approach. Let's go this one. But here we don't have the scoping mechanism, obviously, because your pipeline is just one sort of phase that runs through. So there's all the variables that's associated to this. Actually, I'll get to this a bit later, but yeah. So variables, and these actually, so you see the settable at queue time. If I say I want to be able to change this at runtime like that, if I was to queue this guy now, come on. Yeah. There's my variable. So I can actually change this as I'm busy queuing it off. I can have a default, or I can say this must actually be test 1, 0, something like that. That's all that is. Different notation, anyway. Okay, variables. Let's go back to our releases. Releases. We've got different phase types that we can associate in a release. So this is different to the build where we've just got a bunch of tasks that run. Here we can actually have an agent job which relies on an agent as the build would do. Okay, but we've also got an agent list job. And what we can do with an agent list job, talking about SQL deployments and that kind of stuff, we can actually have, say, phase 1 here, generate an upgrade script for SQL. Take it, put it somewhere. Then on our agent list job, we can say add a manual intervention, send an email to someone to say go and have a look at this, and then sign it off if you're happy with it or not. So you can either approve or reject it. Once he or she is happy with it, then it will carry on and pick up that script and then go and execute it on a target database. The reason we've got agent list version versus agent is so that it doesn't take up an agent, basically. It sits on the server and it waits for an action before it will actually execute anything on the agent. This means that it can actually sit. It doesn't have a blocking effect on your agent. Then once that's happened, we've got another one that we can add, and this is the concept of deployment groups. Now, deployment groups takes this concept a bit further than taking your agents and your agent pools. So if we go and add a deployment group, let's say we've got a QA environment or dev. Let's say dev environment. This long, beautiful script over here, which is PowerShell, is basically what you copy and you paste and you execute on a target environment. So the idea behind a deployment group is you take a bunch of servers. In this case, we've got a bunch of servers that is in our dev environment or a QA environment. Let's say QA. We're getting close to production, so we might have a load balanced website. So there will be 2 web servers, and there might be a clustered SQL instance. So let's say there's 3 database servers. Okay. So what we do is we'll take that script and run it on each one of them, which basically downloads an agent and installs it on that machine and associates it to this deployment group. Then we'll go in here and we'll say tag these 2 machines as web servers and then the others as SQL servers. So now we've got 5 servers, 2 of them is tagged as web servers, 2 of them is tagged as SQL servers. So then we go back to our deployment or our release, which is here. We'll select, I'll not save it. We'll select that, and then we'll say this is our web deployment. So the required tags here will say deploy to everything that has got a tag of web. Then what I can do is I can have my IAS deployment. There we go, app deployment. Here we go. You can set these things up to have the name of the website we're deploying to, etc., etc. What I can do now is I can say, this is if you look at your blue-green type of deployments, you've got the option to say if you've got 2 or 3 web servers, deploy to them in parallel. So then it will deploy to both of them at the same time. Or you can deploy one after the other. It's up to you. And the nice thing about this is then going forward, if you add another web server to it, all you have to do is add that web server into your deployment group, tag it as web, and then this will just automatically pick it up and start deploying to your third server going forward. So that's your deployment groups. And it will obviously execute each one of these on each one of those servers. Makes sense. A lot of information, a lot of jumping around in the web pages. Your happiness. So variables, I've sort of discussed variables and I'll go into it a bit more. Pipelines, we've said triggers, so we've got continuous deployment, we've got scheduled triggers that we can set up there, so deploy every Friday afternoon after hours, whatever the case may be. Build, same thing, builds, we've also got schedules, we've also got continuous, so whenever someone commits something into this repository, it will pick up and start executing the build. Or it can actually, if we're going to have a look at builds, what is here? We can limit the, so if anyone commits to this repository but under this folder, then pick this build up and start executing, or vice versa. Yeah. And okay, so while we're busy with this guy, so once we've now deployed to dev, we can deploy to QA. Let's do that. No, let's not do that. Let's say so we can build out the deployment to look something like this into the different environments, and then we can track it going forward, so we can see where things are being deployed, where they failed. You should be able to see, in this case I've got very simple plain things, but you can see there on the stages, if it had multiple, you'll see them here one after the other, and it will show you green, green, red or white for not deployed there, so you can see where these commits and where these releases are actually deployed to. It's actually okay, so we've spoken about agents, agent pools. Let me show you this guy. I suppose one of the reasons why there's so much churn on this environment, on the pipelines, is because Microsoft is actually using the Azure pipelines to deploy to Azure DevOps. So they're actually deploying Azure DevOps using Azure DevOps. And this is the actual deployment, the release pipeline that they're using to deploy to Azure DevOps. Interesting. Anyway. Yeah. Yeah. I do this quite often, obviously, and the first thing people ask is, how do you roll back? And that is it. You never roll back, you roll forward. And yes, if you want to, if your deployment's gone pear-shaped, then you don't roll back the deployment, you just redeploy a good version of it. That's where it should be. That, of course, has a measure of maturity involved, because idempotency, especially if you start making database changes, that kind of thing, it says there's a bit of cognizance that you need to engage there. But primarily, if that's one of the things you do, you just redeploy a previous version. Microsoft by default do not roll back, and they do not deploy. They always fix and then deploy. That's why they can, they've changed their things to deploy multiple times a day to be able to. So they'll rather fix than deploy previous versions. Yeah. So while we are here, is there any questions? None. Okay. Some of the bits and pieces, the fluff basically around this, and I'm a bit hesitant to actually give you a lot of this detail because, like I said, they're busy changing everything. So YAML will bring in the same concept as some of these things that I'm busy going to show you now. But ultimately, we've got builds. Yes, we're back on premises again. If I go here and I say, this seems to be a fairly standard approach to building a Visual Studio solution, right? We've got NuGet restore, we've got a Visual Studio build task, we've got test assembly, so just run some test cases, that kind of thing. But we want to do that on 10 different projects. We don't want to recreate this every time, even though this is one of the templates, so it's fairly simple to do. So what we can do is we can create this idea of task groups. And the task group is literally taking those, not going to do that. Let's see if we can. Okay, so linking was the next thing that I was going to talk about, but okay. Anyway, so we should be able to just say select, create a task group. It will go and then create a task group, and it's as simple as adding it. You should be able to pick up your task groups and add them in there, and then just reuse it and set parameters. The parameters would look something like that. Straightforward, simple. Let's see which ones are linked. There, one. So there's my task group. There's the parameters that are required, or the variables that is being used in these tasks. If I go and have a look at my task group, there it is. I can go and change it. You'll see those parameters are just specified in there as variable types, so that's how it's picking up what is required. Bob's your uncle. There you can reuse these clumps of tasks over and over again. No references. Interesting. Oh, it's because it's not saved. There we go. There we go. Task groups. There's my task group. They've changed it. There used to also be a tab for them, but anyway, so now it's just included as a generic task. Okay. So that's task groups, and this applies both release and builds. So in future, what they're going to do is they're going to take the same approach for YAML files. So instead of having a task group in this structure, they'll be able to say, reference this YAML file, and this YAML file will have tasks. So that's where they're going to move to, sorry, from the YAML point of view. Okay, so that's task groups, secure files, library. Here we've got two options, or two things in this library tab. And this is one of the things that, in my mind, it's actually relatively new, but in my mind is also underutilized. So if you think about certificates, signing code, certificates, passwords, that kind of stuff, we have the ability to move them out of the general areas of your builds and releases and have them in a central location in Azure DevOps. And we can do this by using something like secure files. So if you've got, like I said, a certificate or a signing certificate or something like that, you can add it in as a secure file, or if there's a deployment file or a web config file that you don't want shared, not that it's good practice to have them like that, but anyway, you can add them in here, drop it off, and then you'd actually go to your builds, and there's a task here for secure files. It's a bit of a headache to use. Download secure files there. Select what the file name is, and then that will go and dump it into a secure location. And I can't tell you offhand what that is because I can't remember it, but it's actually a reference location for you to go and pick it up and then use it as you would. There, temp directory. So it goes and dumps it down there when you download it, and then you can go and actually copy it to a destination or whatever. The nice thing about Azure DevOps as well, I can tell you, is that all your stuff like passwords and secure files and secure settings, that kind of stuff, actually gets hashed out. So as far as, if you look at, let's go and have a look at the summary here. So you see all these steps here. There's detailed logging for each step that happens. And if I had passwords or secure files in here, it actually gets hashed out. Now, a nice thing is that it's actually gotten quite a bit clever in the recent builds. In 2015, when was the first version where the build system came out on premises, one of my clients, what it would do is it actually look for the password and hash anything that has the password in it. So if you have a password with, say, database in it, then anything and everything that had database would have stars in. So if you had a path and there was database in that path, you'll have path, star, 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 path. So you can kind of relate or figure out what those passwords are, but they've gotten a bit more clever than that in the recent builds. But yeah, so in the build logs that you can see, and these things are concurrent, real time. So when the build kicks off, you can actually monitor this and see exactly what is happening, do the details for debugging purposes and whatnot. And you can actually, this is sort of a light version of it. There's a setting when you have system.debug and you say true, it would actually give you the verbose output, which obviously means that in some of the bigger builds, you can have quite a few megs worth of log files that you can troll through, but nonetheless. We were on secure files. The same applies to variable groups. So we can go and set up variable groups. If we had a dev environment and we have a server name of dev and a database connection of, so I can hash out at this level. So if I wanted to keep that private, I will do that, and then connection string. This applies to all the variables wherever, so you can actually hash them at that point. And then I can link my deployment to this variable group and then just use those database or the variable names as I would normal variable names. So I can then reference them. Oh, what did that happen? Okay. Anyway, yeah. So there I can link it to that variable group, and there we go. And I can use them as is. So I need to change the password in one place. So we can have certain people manage these passwords in one location and then just reuse them all over the show. That is variable names, variable library, secure files, variable groups, yeah. And then, that's it actually. Okay, so any groups, any questions? So we looked at builds, or in the new version, pipelines. In this case, we've got the ability to do a classic editor or use YAML files. The YAML files, once you've created it, gone through that yucky process, then once you're editing it, you can actually see the tasks and add them, and it will be a bit nicer for you to use. We can consume those into pipelines, the build artifacts we can consume into pipelines, and then use the pipelines to deploy into different environments or phases. We can link variables, we can hide variables, we can use secure files, we can use task groups and sort of ease our overhead with editing them. We saw how we can schedule builds, we can do continuous integration, we can do scheduled releases. We can do the same with pipelines, so we can schedule it. Once a build is completed, it will kick off. Once a schedule has kicked, it can get scheduled. Yeah. Phew. I think it's due for a break. So if there's no more questions, shall we be back at about 3:10? Okay. Ja.
Ons het 'n common solution wat ons voor klomprojekte gebruik. En wat ons gewoonlik gedoen is op soos 'n source folder, dan check ons die Esri namespace folder of solution uit en dan kry ons die nuwe solution wat van die projekte reference wat in die solution is, op die Esri solution.
Ja, ja.
Kan ons ook dieselfde kan doen?
So tegnies ja. So in Git het ons daar is 'n idee van submodules binne in Git waar jy basies reference 'n ander repository op 'n commit. So jy kan eintlik sê hier's 'n repository, hier's die commit, ek wil dit reference hierson.
Ja, ja.
Maar uiters slegte praktyk. So wat ek vir jou daarso sal voorstel is 'n paar goed, maar eerste ding is gebruik Azure Artifacts. Create vir jou private artifact store en wat jy dan doen is daai common components. Dit is nou as hulle net die ding consume om dit te consume. So as jy assemblies en daai tipe goed kan gebruik, brilliant. So wat jy dan doen is daarso in jou common project, wanneer jy veranderinge maak, compile jy, publish jy hiernatoe en al die ander add 'n NuGet reference na daai toe. So dan kan jy vir hulle sê, hier's nou nuwe weergawe, kry dit wanneer jy gereed is daarvoor. So dit gee vir jou daai segregation om te sê, ons is nou naby aan deployment, ons wil die nuwe weergawe hê nie, of ons soek daai verandering om bring dit af. So dit is die een opsie. Die ander opsie is jou submodules wat 'n bietjie van 'n pain kan wees, maar jy kan dit ook doen. Maar dit gesê in 'n Git terminologie is dit nog steeds ek sê problematies want jy reference nog steeds 'n spesifieke weergawe van daai in 'n ander repository.
Ja. So
jy moet dit dan update sodra jy daai weergawe wil hê. Dit is nou as jy die source code saam wil hê.
Ja, want dit is gewoonlik die twee codebases geupdate en dan as jy changes maak in die main solution of die association namespace project, dan het ons almal apart gekommit en die apart gekommit.
So die by far die maklikste en die beste manier is net om te sê as jy veranderinge soek, gaan hiernatoe, maak die veranderinge, wag vir die pipeline om seker te maak dat die veranderinge gewet kan word, dan publish jy dit na private feed toe en dan sê jy okay, almal kry die nuutste weergawe as jy moet. Dit is veiliger, is baie veiliger om dit so te doen, want nou het jy 'n paar checks and balances voordat dit uitkom. So jy maak gou 'n verandering, maar jy weet nie wat se verandering daai gaan die effek gaan hê van daai verandering op al die ander mense wat dit gebruik nie, daai tipe goed. So dit is 'n mitigation meganisme. Okay. So, pipelines, build, release. Any questions? Shall I say, what are the questions? So, no. In terms of putting them away somewhere? No. You can lock branches, but nah. You can remove rights. So that's probably the easiest way of managing is to actually remove the rights so no one can see it. But beyond that, I'm not quite convinced you can do much else. But yes, you can delete them. So archiving projects. No. Any other questions? So I believe if we look at this, we've pretty much spoken about branching strategies, Git and CI/CD. Okay, so we can go now. Cheers. No. Okay, been a long day. Okay. Going once, going twice. No questions. Okay. Next, we are going to talk about some of the hooks and some of the integration points and some of the administration overheads that come with Azure DevOps services. First of all, let's have a look at integration points. So the whole concept behind Azure DevOps service, when Brian Harris started working on this in 2002-ish, his whole intention was to create an open platform and to use this in to be open so that people can actually access it in whichever way or format that they want to. Now back then they created, well actually not back then, about 2008, TFS 2008 or Visual Studio Team System 2008 I believe it was called then. They had an object model which was a .NET library which would actually call the SOAP services and you could interact with TFS using development approaches. That object model is very close to being removed completely because the way that TFS or Azure DevOps services is exposed currently is RESTful services. So pretty much anything and everything you can do through Azure DevOps services, be it Visual Studio, be it through the website, is exposed via RESTful services, which makes life quite easy from a cross-platform point of view. So we used to actually have a Java set of object models, we used to have .NET versions, now it's all just, there's the RESTful services, connect and go nuts. This also works quite well from a, see if I can remember what it looks like. Nope. Ooh. That's not good. So if you have a look here, this is version 5. You can go back previous versions to even on-premises versions, but get lost. There's all the definitions for it. So if I'm going to look for, say, work items, I can say I missed one. Come on. Okay. What am I doing wrong? Okay, well, I'm doing something wrong, must be. Anyway, so that's pretty much how it looks. So you can go and query pretty much anything in here using REST items, RESTful services. And the actual same applies to the OData. So just carry on. Who's worked with OData before? One person. Okay. So this is actually quite interesting. So this is part of the analytics, and I'll talk a bit about the third-party extensions that you add into it. But this is one of the things that you can do once you've installed the analytics plugin, and this is actually quite powerful. So when we go and say, let's see if this works. Getting closer. Ha! In your face. Okay, so this is just an OData endpoint that is exposed via the analytics. This gives you access to your data. And if anyone who knows OData has played around with, you can go and create query strings on as part of your OData definitions. So for example, you've got selects items, you've got filtering items, you can go and create all of that nonsense through your query strings. I'm yet to see what happens when you hit the 255 character limit, but yeah. And you can do quite a bit of interesting stuff. So Where's the aggregation, trend data analysis, work item links, exploratory, all that kind of stuff is now exposed via OData. So anything that understands the JSON package, you can go and query and bring this information down. Create your own graphs and that kind of stuff, such as Power BI, for example. Okay, that's just by the by. In any case, we are not actually talking about that. We're talking about the open system that is Azure DevOps, organization settings, and I was talking about service hooks. Okay, getting sidetracked. So, service hooks. Where's my projects? Couple of the extension methods. As I said, you obviously have RESTful services, you've got OData services, but in some events we can actually use Azure DevOps to call into other systems, to either third-party systems. And one of these mechanisms is the service hooks. There. I showed this briefly earlier, but this gives us the ability to react on events. So whenever an event occurs within Azure DevOps services, we can call out to another system. As long as this server obviously has access to that service, we can pretty much do whatever we want. And look at, these are sort of out of the box stuff, so there should be there's a Trello, there's a Slack, Zapier if you want to send out SMSs and stuff, Bamboo if you're using third-party build systems, Campfire, Hockey app, even though that's coming to the end of life, quite honestly. So these are now built for this. You can go and build your own if you have specific service hooks, specific mechanisms for them to work. The easiest one to work with is the webhooks, because webhooks is just a standard mechanism for dealing with stuff. And then with this, we can decide on what event to push through. So we can say if a build is completed, call into another system. Some systems use webhooks by default. I came across one the other day, can't remember what it was. They actually understand webhooks. You guys use Teams, Office 365? Maybe someone. You can call out to Teams. Anyway, so if there's an event that you can listen for, build completion, this will actually send through a JSON package, pretty default standard stuff, and then you can react on it. So you can also go and create like a Azure function to react on this and do stuff if you wanted to. As I said, there's a bunch of different events that you can subscribe to. So if there's a work item created under specific criteria, then call into this URL, this authentication, etc. Each one of these obviously has a different sort of setup. So Slack, for example, has a authentication token that you add in. So that webhook URL is something that you'll go and set up through your Slack environment, and then it will post into those channels for you. So that's service hooks. Okay, so this is Azure DevOps services notifying other systems. Now, if we look at, for example, our build environments and our release pipelines, there are some circumstances where we actually need resources, or we need to interact with other systems. And to accomplish that, we've got the concept of endpoints, service endpoints. So if I go and have a look at this guy, for example, come on. Okay, if I add a Azure resource, for example, you'll notice that it's going to ask me stuff like my Azure subscription. And the way that we push this through to these artifacts is we will go and create a service endpoint. There's a couple of different endpoints that we can go and create, and this will now, basically it's a endpoint location and credentials or authentication mechanism. That's what these are. So if you even look at the generic one, for example, name, URL, username, password. So this is now giving you a mechanism to authenticate to a third-party system and interact with it. In this case, the ARM templates will use that to, which I actually have here, will connect to a subscription sitting in Azure, and that will give the task the ability to go and create resource groups to actually execute ARM templates and create the resources as assigned in the ARM templates. So service hooks push information out. Service endpoints or service connections, which is probably more apt, is a way to connect this to another service and actually interact with that service. And as you see, Docker, GitHub, Jira, there should even be Subversion. This is actually, so see, out of interest sake, I'll just be aware. Okay. Anyway, so connect to different systems. Okay. Well, while I'm here, so this is the stuff. A lot of these are built in, so they come sort of out of the box for you. The other way of actually adding to this and adding to different areas within the platform as a whole is to use extensions. And extensions, we have this ability to go and pick them up off of the marketplace. So first of all, we've got extensions that are already installed and available to us. But firstly, come on. These are extensions that I've already installed into this organization. If I want to add more, I will say browse the marketplace and then go and select some extensions that I want to use. So Barent actually goes quite nuts with the number of extensions that's installed. So him at his previous work.
What I've seen with the extensions is, for example, one I asked you to stop and start a Windows test. You could go write the Powershell and do it yourself. But somebody needs to create an extension, don't you?
Yeah. So I generally see the sort of escalation to get extensions is have a look at what is built in, if you can do it. If you can't, go and have a look for an extension. Just be wary about which extensions. There are some really crap extensions on here. Case in point. But so have a look if there's an extension. Then the next step is to script it. So you can use PowerShell. PowerShell is cross-platform now, so you can actually go and do a lot of the stuff that you want to do, or use a bash script or a command script. The actual, if you look at that command line is actually a cross-platform command line. So all that this gives you is the ability to go and add a script, and it will run it. If the agent is running on a Linux environment, it will run it as a bash script. If it's running on a Windows environment, it will run it as a command. If it runs on Mac, who knows what it runs at, but it will do what needs to be done based on the context that it gets running. So you can do that in PowerShell. I mean, obviously, in PowerShell to start a service, stop a service is literally that, but if you want to have the task, it's fine. Yeah. Yeah. Yeah, no, it's anyway. These also hook into, so once again, TFS or Azure DevOps is an extensible system. You can plug into different areas within Azure DevOps. So you can go and add new, tabs sitting over here. You can add tasks here. You can add, on the work item, you've got extension points. So you can add functionality in work items. There's a couple of them that do roll-ups of tasks. There's a couple of them that actually do time capture systems and integrate with other systems. And there's now, they're doing a lot of analytics and stuff. So let's see if my summary. So all of this is actually just extensions that Microsoft is now writing and actually incorporating into the system. You'll see okay, I don't have it installed here. Where do I have it installed? Let's try you. There. These are, okay, the dependency tracker, that's a Microsoft extension. The analytics actually comes through as an extension, although in the Azure DevOps server it's going to be installed by default coming the next version. So even Microsoft is now busy providing functionality on Azure DevOps as extensions. I mean, you can probably see, there, test and feedback, Microsoft, code search. These are all extensions. There's your analytics services. So if I go and say Sonar, this, interestingly enough, was one that, was one that Microsoft wrote and Sonar Source actually took over. And where's my source connections? Oh, come on. This should have given you oh, maybe I put in the wrong one. This should have given you a Sonar Source connection that you could set up. Probably using the Sonar Source one. Try this one. There we go, that looks better. I don't know what I was doing just now. Anyway, so you can see I've now added extensions and they've actually added their own connection infrastructure. So if you connect on these, you'll see that it has a slightly different connection mechanism than, for example, a generic one which has a password and token example. Okay, so extensions, marketplace. Marketplace is a good place to go and have a look and see. So a lot of the stuff, plans is one that also is on here. You can see there's quite a number of extensions that is already available. Most of them are free actually. So extensions. So service hooks, we've looked at a bit about the REST services. We've looked at marketplace and what is available. Obviously your rights need to allow you to be able to install it, else it will just ask you to send a request to the admin to install an extension. Service hooks, endpoints, licensing. Licensing comes in a couple of variants. So this is what licensing looks like from a Azure services versus server approach. This is what it is going to be looking like. I think this is public knowledge already. Anyway, I updated these recently. But services, basically, you've got different ways of licensing it. Stakeholder obviously is free, but you have limited rights to do what you want to do. You've got subscriptions, and subscriptions already come with a server, with a user license. So you're covered if you've got an active subscription assigned, and you must just make sure that these subscriptions are actually assigned to you through your AAD and your subscription mechanisms. Then we've got basic users, which is basically just $6 a month, and that is going to be changed to this is public, so it's going to be changed to everything except test plans. You now will be able to do using a basic license. And obviously, like I said, your subscription includes this, but you can purchase a $6 a month basic license. Then you've got basic license plus plans, test plans, and then you've got Azure Artifacts, which has now literally Monday switched over to a consumption model. So where you used to have a separate license for artifacts or needed enterprise MSDN subscriptions to use Azure Artifacts, they're now working off of a consumption model, meaning the first 2 gig is free. So you can upload, create private feeds, you can use it as a feed proxy for your organization. That makes life a lot easier in the consumption of these artifacts. And it also means that anyone can consume it now. So you can make it publicly available or keep it locally. Yeah, I'm not even going to worry about that. There's a lot of text there. Then finally, we're going to talk about security. This is probably one of the hardest things to talk about, and lucky we're about half an hour ahead of schedule, so we've got lots of time to talk about security. Some of you are awake. So basically I just want to cover security in terms of, firstly, when we go and start our new Azure DevOps. So you can go and create an Azure DevOps instance. It's free to create. Up to the first 5 users are free, so you can start using it without paying a cent, basically. Once you get past that first 5 user threshold, then you start paying, or if you've got an MSDN subscription, you're already covered and you can just carry on using it. When we start looking at this, they are moving towards having one license across all organizations. It's basically going to get licensed through your AAD environment, your Azure environment, but that's a whole ball game on its own. So if we look at Azure subscription, at this point we've got users. You would add users in a specific license access level. So if we say add new user, we've got, like I said, basic stakeholder and subscriber. Stakeholder, like I said, bunch of stuff for free, work management primarily. You can run test cases for free, no problem. Basic gives you access to pretty much everything, and Visual Studio subscription as well, excluding test cases, of course, that's additional. Once you are added as a member of your organization, then you can get assigned rights to stuff in your organization. The easiest is probably to, where's my mouse? To select the project that you want rights to, and this will give you contributor rights into those projects. In fact, if you select it, you can actually select what level of rights you want, readers, contributors, and admins. Once you are in the team project, once you've been assigned there, the level of rights is very granular. This is also one of the things that they're looking to try and ease a bit, the management of rights. And by far the easiest, and I found the most convenient, is just to add people into contributors and maybe elevate them to admin when needed. That said, at each one of these levels, we've got rights that we can go and set. So at team project level, we've got a bunch of stuff we can do. You'll see these are sort of out of the box, your contributors, endpoint admins, that kind of stuff. There's a few rights, and this will be in the test that we'll be doing later. So learn these, and then you can set the members and groups. We've got two also approaches here. So in this case, because you could be linked to Azure Active Directory, you can use groups in Azure Active Directory and sign those groups in here. Or you can create a TFS group and manage them in here. How you do it is pretty much up to how much access you've got in Azure Active Directory. If you can set and manage groups in there, use it. And you just manage the groups assignment over here. If you don't, which is quite often and happens quite a bit, then you'll manage groups and add TFS groups in here. And then you can just manage people in here and assign rights to the groups. Okay, so that's your team level, and then you delve down. So all the way down to iterations and areas, so we can decide in this iteration we only want certain people to see what is the work items associated into this. Git repositories, unfortunately or fortunately, you work off of branch level and repository level. In TFVC you can go down to file level restrictions to what people can do, what they can't do. Test case, same approach, you can set up security there. So there's a lot of areas. I think I saw a talk about the guy who's managing all of this and trying to simplify it. He said there's about, he counted about 30 odd places in TFS where you can go and set security. So it can get overwhelming quite quickly, and as I've also seen people do things quite out of the norm. I've had one client that couldn't see stuff in version control in TFVC because he'd remove all rights from it. So yes, and it took quite a while to figure out what was going on because he was trying to delete stuff. That was fun. Yeah, so some of the things that you need to be aware of, like I said, security, contributors. When you are using builds, to be able to select your agent pools, we've got this concept on agent pools, right, of users and administrators. So to be able to assign an agent pool to a build definition, you need to give them rights to be able to assign an agent pool to a build definition. And that's also one of the steps that I see a lot of people struggle with. So yeah, a couple of places you can set up right. So you can get very granular, but general convention, and I actually agree with it, is give everyone admin rights for argument's sake. It's easier for people to mess up and have it fixed than for people to sit idle and not be able to do what they need to do. Okay. So that pretty much covers access levels and licensing and security overview. Are there any questions? NuGet, in terms of? So, you just out of interest sake, you see the verticals that I was talking about? This new concept of managing projects. One of the things that we can do with these verticals is put them on and off. So you're thinking of this guy, artifacts. So artifacts is the feed management in TFS, and talking earlier about, you know, shared resources, shared libraries, that kind of stuff. And what you want to do is, if I put this on, you should see it pop up back over here. This basically creates our own private NuGet repository. Well, it's not actually a NuGet repository, I lie. It is a feed repository. So I can create a new feed. And I can connect to any of those. So what this allows me to do is, instead of having an Artifactory installed locally or a Nexus or one of those guys, I can use Azure DevOps. And there's your pip packages for the Python lovers amongst us. But so this gives us more control over what is consumed inside this organization. So when we set this up, we'll set up Visual Studio. We can set up end-to-end to use this as our default registry. We can then manage what versions, who's got security rights. We can see who's consuming those versions. More importantly, we've got this concept of a universal package. So what this allows us to do is actually publish stuff into here. So we can go and, in the case of shared libraries or shared projects, instead of having to reference the code or the solutions or projects in our project, what we'll do is we'll have these, manage them separately. So if there's a change, make the change, check it in, have the build, run all the tests, make sure that the validation has passed, send it to SonarQube to make sure that the static analysis passes. Once all of that is happiness, we can take those artifacts and publish it to a universal package. Then everyone else using those shared libraries have the option to say, okay, we are in a situation now where we can actually update to the next version, or we are now needing to deploy fairly shortly. We do not want to use the new version because it's not going to give us any benefit, so then you'll just use the version that you're currently on. Instead of getting code that is changed and then suddenly on your compile, it's failing because someone changed it for some other reason and now it's messing up your environment. Is that the feeds you were talking about? Yeah. And like I said, this is now consumption based. So you've got up to 2 gig for free, which is, I believe, covers 98% of all the usage of artifacts in Azure DevOps. Yeah, so this is primarily, the universal packages is a, I don't want to say dumping ground, but you can put in config files and that kind of stuff in there, yeah, sure. But obviously your NuGet, Node, Maven, Gradle, Python, they are more often than not artifacts or compiled libraries in some form or the other. Gradle maybe, but you know, assemblies, whatever the case may be. And I believe that there is, I must actually go and check, but it's, I think said something like 50 odd terabytes of storage that they're using on this alone. Azure DevOps services. Most of it obviously your Windows and Office environments, I'm sure, but still. Yeah, so this gives you a nice way of managing your repositories locally. And if this is also available on premises, and I usually tell people this makes a nice change to wait for Node packages to download. You can just download it from a local source as well. Because we all love having Node. It's like a 10K source file, and once all the packages are installed, you're sitting at like 200 meg, something silly like that. Yeah. Okay. So we are now, give or take 20 minutes ahead of schedule. So it's going to be an early day for us. Any questions? Any comment? Any discussion points? So is he interested in using this system? Oh boy, I'm sorry. Does it look interesting at least? We've covered a lot of stuff. The idea behind all of this is just to sort of give you some insight into what is available, what is there for you to use. And the idea is then that you actually go and look at the areas that is of interest to you. So, yeah, version control is probably a good start. Work management, when there's a task associated to your check-in, and then set up your build pipelines. So, any feedback? No? Yes? Did I? This is that Azure DevOps Labs that I showed you in the beginning. So there you can see agile planning, okay, project schedules, configuring code, continuous integration, deploying to multi-containers, Kubernetes. You use containers here yet? Docker, Kubernetes? No, not yet. Okay. Feature flags. So there's a lot of stuff that it contains here, and you should be able to get the code, but I am looking for the actual lab. Technic Labs. I've changed the site, but somewhere over here you can actually log on to the Technic Labs that actually have VMs running in Azure, and you can start working and playing around in those labs if you wanted to. In fact, There we go. So it's on the DevOps service stuff. And you can actually also download this VM, which is the one I've been using, from there. I think it's about 20 or 30 odd gig that you'll download. So if you're interested, play around with that, get to grips with what the thing is, and the documentation on the docs.microsoft.com is fairly comprehensive and fairly up to date as well. They sort of put in quite a bit of effort in that, and if you have any issues, then you can just raise a pull request or notify them, because we do that quite often. Okay. Well, if there's nothing else, then I'm not going to keep you here. Or if you're happy to just sit here and stare at the ceiling, it's fine by me. Okay.